Alrighty, this is a video about looking at molecules in 3D to actually see what the shape of molecules looks like. We've drawn lots of Lewis structures already, but now we're going to think about what those molecules would actually look like. So these letters, this is the system that we use to draw these. This stands for valence shell electron pair repulsion. And so the whole basis here is that electrons are negatively charged, and so they need to be far away from each other. They actually repel each other. And so areas of electron density, which can either be bonds or electrons, and usually these are electron pairs. So bonds or electron pairs are arranged around the central atom to allow for maximum space between those bonds and electrons, okay? And so the geometries can be pretty complicated. We're going to look at a few simple ones here. So here's the first way that we can look at a molecule. This is the simplest shape that we can take. These are called linear molecules. And this just means that there's no extra electron pairs on the central atom, and you'll see why that's important here in the next example. But examples here might be like hydrogen bonded to hydrogen. You know, this is a linear diatomic molecule. This one might be like carbon dioxide, as we know, looks like that. So that's a linear molecule, and you can see that carbon has no excess electrons around it, which keeps the shape linear. So the bonds try to be on opposite sides of the central atom is basically the idea. Okay, the next shape is still pretty easy to understand. This is known as a bent molecule. And the reason that it's different than a linear molecule is because we have pairs or a single pair of unbonded electrons on the central atom. And so here, like this, electron density means a bond pair or an unbonded pair of electrons. Those are what we mean by electron densities. And so here we have a total of 4 electron densities that are trying to spread out as much as they can from each other. And it turns out that in 3 dimensions, that they're able to spread out in a pretty interesting shape. An example of this is like a water molecule, where we have our oxygen with the 2 electron pairs bonded to 2 hydrogens. That's a bent molecule. Now, if it weren't for those electrons on top of oxygen, this would be a linear molecule, but those electrons fight for space and they push the bonds down to look like a bent. So the angle we're talking about is the angle formed from the peripheral atom to the central atom and back to another peripheral atom. So that's a bent shape like that. That also occurs when there's only 1 pair of unbonded electrons on the central atom. So an example of this is like SO2, S double bonded to O's here, and then there's a pair of electrons like that. So a pair of electrons or 2 pairs of electrons on a single central atom can affect the shape for sure. The next shape is called trigonal planar. These actually are sort of uncommon. These are exceptions to the octet rule because there's no extra pairs of electrons on the central atom, and as you can see here, this central atom only has 6 electrons around it in these 3 bonds. The central atom that is almost always in a trigonal planar molecule is boron. Boron is an exception to the octet rule, so if we made boron trifluoride, it would look something like this, right? And boron just, all it needs is 6 electrons. It's just one of those exceptions. Okay. Trigonal planar can easily look a little bit like trigonal pyramidal, and as you can see here, we've got a pair of electrons that are unbonded sitting on the central atom. And because that's an electron density, it fights for its space and pushes these 3 bonds down, and so everyone has as much space as they can get. So if it weren't for the electrons on top here, then you'd be looking at a planar molecule. but because of those electrons, it's got a three-dimensional shape. And usually the central atom here is nitrogen or phosphorus, and that's because nitrogen has a Lewis dot diagram like this, and that's perfect for bonding three other atoms, and that pair of electrons on top there is not available for bonding. So nitrogen and phosphorus is kind of that way too. Those are your usual central atoms for this. And our last shape we're going to talk about is known as a tetrahedron or a tetrahedral geometry. This is where we have one central atom and four peripheral atoms, and there are no pairs of electrons that are unbonded attached to the central atom. And so example of this, for the central atom, this is almost always carbon. Carbon has a setup with four single electrons in its valence level, and that really lends itself well to making four single bonds, especially to something like hydrogen or whatever. And you can see here that the way I've just drawn this, that's a two-dimensional representation of CH4, but in reality, you know, you would say that this bond angle is about 90 degrees, right? But in reality, in 3 dimensions, these are able to spread out to a much bigger angle than 90. Okay, so that's the basics of the geometries that you're going to need to know in our chem class. All right, good.